Mrs. Shermana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. As we are seeing in detail the programming techniques in the C programming language, today let us look in detail at the functions that are available in C. Now what is a function in C? A function is a self-contained block, subprogram, subblock or set of statements that performs a special task or a specific task when it is called. So as such it does not perform any function. When there is a need and we want that particular set of statements to be executed, we have to call that function for it to execute. Every C program is a combination of one or more functions. We all know that the starting point of a C program is the main function. The main itself is a function. So the entire C program itself consists of a function. In order to divide the program's problem into sub-problems and individually analyze it and solve it, we go in for these other functions. Every C program starts with a user-defined function that is called main. A user-defined function is one which is defined for the user's need. The main function calls the other functions to share the work. So the main function is the main program of C. The other problems which are solved by the other functions have to be specifically called from the main function if the particular set of statements are to be executed. So this is the basic logic behind using functions in C. A function is a subset of statements of the main program. So normally instead of solving the entire problem in a single stretch, we divide the problem into smaller tasks, assign a function to solve the subtasks, then we combine it in the program and we solve the entire problem. So this makes it easier to divide the work among programmers as well as it gives a neat structure to every program in C. So what are the different types of functions that are available in C? The two main types of functions are the library functions or the user-defined functions. The library functions are also called built-in functions. So we will see in detail what is the work of these library functions. So as I said, another name is built-in, that is they are inbuilt in the C language itself. They already have a predefined name. They have a predefined set of functions that cannot be altered by the user. If we want the set of functions to do their work, we should simply make a call to that function. Their task is limited in the sense it is already defined. Why we say it is limited? Because C language was written many years ago. So its task is limited only to the applications that were existing at that time. Nowadays, number of applications have to be solved. So the library functions sometimes seem limited in their power because their task is defined already. They can do only what they have defined. They cannot be extended according to the user's need. We cannot make any modifications to it. We can simply use these functions. They cannot be modified by the user. There are plenty of library functions in C. Just an example is SQRT. SQRT stands for square root. When we give the square root function and we give the number whose square root is to be found, automatically the C program will give us the result. So this also, SQRT has to be written the same way, and within it the number has to be given within parentheses, and for a single function only a single number can be calculated. So all these are the limitations of this library function. The name of the library function, the way it is to be written, the syntax, the rules that apply to it, everything is predefined. So we have to follow those specific set of rules to get that work done by the program. Next, user-defined functions. From the name itself we can find out that they are defined by the user. So that depends upon our application and our need. They are defined by the user according to his or her own requirement. And the user can modify this function and we have full scope in the sense full rights to implement our ideas in this function. We can define the name as we wish. We can give our own variables, any number of variables, different data types, and we can have any number of statements in a function and we can call it whenever we want. This can be made available for use by other programmers also. So the function, say for a certain application we are writing this particular function, it can just be taken from our program and inserted into some other program also and used by another programmer. So that freedom is available. The square of 9 gives 81. So this square is a name that is given by the user. The number is given within parentheses. So this function is not built in. If you simply give square of 9, the compiler will not understand. What does the square of 9 do? Has to be defined by the user, only then the compiler will return this result. So the source code for this function is created by the user itself. So how is a function declared? How do we declare a function in C? It is similar to a variable declaration. Why are we going for declaration? The compiler is supposed to know that such and such a function exists later in the program. So that reason only we are declaring variables. So similar reason we declare functions also. The compiler should know beforehand that such and such a function is used in the program and its definition is given somewhere in the program. So what does the function declaration contain? Contains a function name followed by arguments or parameters or variables. They are just another name for variables. You can call them arguments or parameters. They should be enclosed within parentheses and they should be separated by comma sign. You have the argument declaration. Argument declaration is nothing but what are the variables or arguments used in the function or in the program. They have to be declared here. You have the opening brace. You have the local variable declaration. We will be seeing in detail what is this local and global variables. You have the set of statements and you have a return value. So return value is nothing but a function may or may not return a value. So based on whether it returns a value or not, you give this return statement. Now each of these parts of the function we will be studying in detail. So function declaration simply consists of the function name and the argument or parameter list. Normally a function declaration has to be terminated by a semicolon. Following it you have the arguments which are also terminated by a semicolon. And you have the body of the function which contains the local variables, the set of statements and a return value. So when we see the example programs, we will be able to understand better how these are put in place in a C program. So how does a function work? We know that every program starts with the name and then you have the declaration and all that, and you have this part called function call and actual arguments. Now always remember, every function has a name and it has a set of parameters. So the place where you call a particular function to do its work is called the function call. So that also contains the name of the function. The name of the function is indicated by this. And these are the set of parameters or arguments or variables. Now the variables that are mentioned in this function call are called the actual arguments. And then you have other set of statements in the body of the main function and you close this main function. Now this is called the function definition. Function definition is where what is that function supposed to do. When you call a particular function, what for you are calling it, what is the purpose of that function. So that is defined in this function definition. So here again you should have the same name. Here if you see A is capital, here also A is capital, and B and C, here also it is in small. So the name should be so similar. C is case sensitive. So even this is very important. And here you have the set of parameters. Here if you see, the names of the parameters are different. Here you have XYZ and here you have LKJ. These are called the actual arguments and these are called the formal arguments or parameters or variables. Now the number and data type of these actual arguments must match with the formal arguments, but the names need not be the same. So this is only called the function definition. And here you have the set of statements which tell what the function does, and here you can have a return value. If actually you don't have any value to return, you can simply give return 0 or return 1, or you can simply even leave out the return statement. It doesn't lead to any errors. But if you are going to not return any value, you have to declare that this statement does not return any value or this function does not return any value. Normally we give it as void. But if you give say some data type like integer or character, you have to make sure that this function returns a value. So anything that precedes the name of a function, now normally we specify the return value in this place. So if you are going to give void over here, you don't have to return any value. But if you give some data type like integer or float or character, you have to make sure that you return a value like that from the function. Okay, these are the rules that govern the use or the working of a function. We will see in detail now how these functions work together. So these are the components of the function that we had seen now: function name, function call, function parameters, definition, local and global variables, and the return value. So what is this function name? Now what are the rules that govern the use of this function name? It must follow the same rules as we use for variables. So for variables we know they can be a combination of letters or digits, but the first letter should be an alphabet. It can be in a lower or upper case, and after the first letter it can be letters or digits. Every function must end with a semicolon. That is, when you give the function declaration, it should end with a semicolon, like we see here in this example. Sum of int a comma int b followed by a semicolon. Sum is the name of the function. Int and a and b are the integer variables or arguments. They are of type integer. So this is how a function name should be declared. Next, a function call. I had already mentioned what is a function call. It has to be done within the main function, and every time you call the function, the set of statements in that particular function will be executed. So how does the compiler execute? It executes a function when a semicolon follows a function name. So from this we indicate that every function call also is to be terminated by a semicolon. And what does it contain? How should a function call be formed? A function name should be there. It should be followed by a semicolon with the set of parameters. So that is what indicates a function call. The example has been given here. Calculate, int x and float y. So calculate is the name of the function. It has two arguments, actual arguments. One is of type integer, another is of type float, and it is indicated by the semicolon that it is a function call. Next, you have the function parameters. This is nothing but the actual and formal parameters that we have seen. The rules that govern the use of this are: the variable names should be enclosed within parentheses. So that is very important, and they must be separated by a comma. Like if you have a single variable, it's not a problem. Say you have two or more variables, whether of the same data type or different data type, you have to separately show it using a comma symbol separating the variables. And the types are, we have seen actual parameters. So the variables that come in the function call are called the actual parameters. That is where they are terminated by a semicolon. The formal parameters are where the function is defined. So here that function name followed by the set of parameters and all don't have the semicolon. Here only we actually define what the function is supposed to be doing. So the parameters in the calling function are called actual parameters. The ones in the called function or function definition are called the formal parameters. Now here comes the important part of the function definition. Now what does this function definition mean? The set of statements that perform the specific task. So what is a task performed by the function? And whenever the compiler encounters a function call, it searches the program for the function definition and executes the statements defined within it. So as I told you, when there is a function call, the compiler needs to know that such a function exists in the program. So that is the reason we declare a function beforehand. So it searches the whole program where the particular function is defined. How it will search? Using the function name and the set of parameters. So when it searches for the function and finds it, it jumps to it, executes a set of statements and returns the control to the main function. So we will see the other components of the function after the break. Welcome back after the break. So before the break we had seen about what is a function, the need for a function, the different parts of a function. We had seen about the function name, the rules governing it, the function call, the parameters and function definition. Now we will see about the local and global variables that we had seen in the function declaration. So what is the meaning of the word local and global variable? We all know what is a variable. A variable is any name given to identify a certain value in C. So this local variable is nothing but, from the name itself you can identify its scope is limited. It is local to a particular function. That means it is defined within the function for use inside that function only. C consists of many functions. A C program may have 2 or 3 functions in the program. So if a variable is considered local, it is defined only in one function, it can be seen only by that function and it can be used only by that function. So it's defined within the function body, accessible only to the container function. That is, whichever function has defined it, only that can use this variable. Other functions cannot access, cannot see and cannot use these variables. So they are local to that particular function where they are defined. So that is the meaning of the word local variable. Global variables are defined outside the main function. That is, even before the starting of the C program they are defined. say after the header files. We all know the header files come first, after that the main function starts. So between the header files and the main function, generally these global variables are declared. So global in the sense they are accessible by all the functions in C, they are visible to all the functions and they can be used anywhere. So multiple functions can use them as they are defined outside the main function. So this is the definition of local and global variables. Then we have this return value. So return value is nothing but the value that is given by the return statement. This is actually the outcome of the function. Normally what we do is when we call a function, we expect that function to return the result as a value to the main function. But in certain cases we may print the result in the called function itself. So that depends upon the user's choice. Normally when we return a value, it is expected to be the result of that function. Whatever computation that function has done, we expect it to send it back to the calling function. So the result obtained after function execution is sent back to the function which called it. Normally we return only one value per function call, though in certain cases there are exceptions where we can return more than one value from a function. Exit from the called to the calling function is done by this statement. Like we have seen what is a function call. It normally occurs in the main statement or under the main function. So you are calling a certain function and that function gets executed. How does the control get back to the calling function? So there has to be some point at which the compiler understands that, okay, now the function which is called is executed. Now I have to get back to the executing program or to the controlled program. So for that reason normally we have this return statement. If the return statement is missing in a certain function, then the compiler identifies from the closing brace that the function is terminated. Now I should return control to the function which called this function. So the return statement is a explicit indication to the compiler that the function block is complete, it is over. And normally when we have a return statement and we give a value, that value has to be collected by a variable in the calling function. For example, if you see here, a is equal to abc int k int l. So abc is a function which is called. You are passing two actual parameters. The return statement, the return value that comes from that function is assigned to a. So that is what we mean by the value has to be collected by a variable. So the result of that function is assigned to the value a. So this is the use of the return value in the C programming language. Next we move to what are called function prototypes. Now all of us know what is the meaning of this word prototype. A prototype is nothing but a model of the actual thing that is expected. Similarly, all functions have a prototype. They are generally considered a must in the C program, but sometimes there do exist programs which do not have this prototype. So again, what is the use of this prototype? It helps the compiler to check the correctness of the function. For example, a function prototype is normally declared before the definition of all functions. So the prototype just indicates to the compiler what is the model of the function that follows it. So this enables the compiler to check whether the function is defined according to its prototype or whether there is any variation in it. So what does this prototype contain? It contains the function's return type, the name and the argument list. So return type I have already mentioned before, it can be void if there is no return value, or it can be an integer or float or any data type. Then the function name should be there, only then you can identify the function, and the argument list. See, an argument list can be a single variable, it can be multiple variables, they can be of same data type, they can be of different data type. So all this has to be checked by the compiler. And when the programmer defines a function, the definition of the function must be the same like the prototype declaration. So that is why a function's prototype is declared before all the definitions. So the compiler checks whether the prototype of the function matches with the function definition. The function definition should be the same as that of the prototype. And the prototype must always be terminated by a semicolon. Here's an example. Float is a return type. Sum is the name of the function. You have the argument list of a float and an int, and you have the semicolon. Here if you see, the argument names are not given. It is not given as float a or int l or int k and s. That is not required. It is only a model. You have to make sure that the function called sum returns a float value, and it is having two variables, one of type float and one of type integer. Say in the program you define a function like this, float sum int a int b, then the compiler will reject it. It will show an error because that does not match with the prototype. The prototype gives a float and an int argument list. Then the definition also should contain a float and an int argument list. So that is the usefulness of this prototype. So here is an example of the way a function is defined. Now here we are simply adding two variables and defining the sum. So if you see first function prototype, integer is a return type, add is the name of the function. It is having two variables of type integer terminated by a semicolon. So here it is declared before the main function. Then you have the function name, the opening brace. You are having three integer variables, x with a value 1, y with the value 2, and z that is not initialized. So here the next part, if you see, you are having the function call. In the main function you are calling the add function using the two variables x and y, and you are calling this function name add. Now here if you see, there has to be a return value. Why? Because you are having a variable z here to collect the value. So z gets the outcome of the function. So this is how you make a function call. So as soon as this function call is seen by the compiler, it will start searching for the function, and here it finds the function add. It checks now whether it matches the prototype. Add is the name. Yes, it is returning an integer value, and it is having two variables of type integer. Now how does this find out the type? Here it is declared integer x comma y, that is only being passed to this function. So this x comma y corresponds to this a and b, both of which are integer values. But it is always better that, or it is a must that you declare the variables here also. Here also you specifically give us int a comma int b. So that makes it easier for the compiler and speeds up the execution. Some compilers may not accept it if you don't give it over here. So that int a comma int b is a must over here. So that means two integer variables. It matches with the prototype, matches with the function call. So the compiler decides, okay, this is a function that is to be executed. And then it comes over here to this add of a comma b, and it performs this value, return a plus b. Now we know what's the value of a. X corresponds to this a, y corresponds to this b. So the value of a is 1 and the value of b is 2. So return a plus b means return 1 plus 2. That means it will return the value 3. That is collected by this variable z. And then it is printed over here. Z is equal to %dz. So the output z is equal to 3 is printed. This is a very simple program. This is all these sequence of operations have to be clearly followed by the programmer if he has to write the program according to the compiler's understanding. The prototype, the name, the values of the variables, the data type of variables, whether the number and the type is right, and then the return value should be collected by another variable. So that's how the value goes to this z, and that is printed as the output. Next we are having the type of functions based on their arguments and return values. Functions without arguments, with arguments without return values, with arguments and return, without arguments but with return values. So we'll just see an example of each of these. So without arguments and return values, here if you see this function ABC, only the name is there. There is no argument and no return value. So the called function is also similar to that. No argument and no return value. With arguments, here there is one argument and here also there is one argument, but there is no return value over here. So all these are just ways of defining the functions. Here you are having arguments and you are having return values as well. So when you have a return value, that is rematched with this z. So when you are returning a value y, it goes into z. That is very important. If you simply return a value and no collecting variable over here, it will lead to an error. The final type is where you are not having any arguments but you still return a value. So again here this y matches up to this z. You need not have arguments but you are returning some value which is to be collected by a variable. So these are the different types of functions that we have seen, the different forms of the function, the type of arguments that are passed and the return values. Now what are the questions that can be possibly asked from this is, how do you define a function? We know we define a function with its return type, name and argument list. The types of functions normally we should say here library functions and user defined functions. The working of a function we have seen, you have the function prototype, the function definition, you have the function declaration, have the function call, then the function definition. So what is a function prototype? It is a model of the main function that is to be. It helps the compiler to check the correctness of a function. It has a return type, the function name, the argument list, and it has to be terminated by a semicolon. Actual and formal arguments, the parameter list that comes in the function call are the actual parameters. The parameters that come in the function definition are the formal parameters. Their number and data types should match. The types of functions in C based on the return type and arguments is what we had seen last. The different types of arguments and whether they have return values or not, and when they have return values, it should be collected by a variable. Otherwise, it does not indicate to the compiler where that return value should go. And if a function does not have any return value, it is always better to use the keyword void, indicating that it does not return any value to any function. So, summary of all that we have seen in this session. We have the function definition, which is nothing but a subblock or block of statements which solves a subtask of the entire program. You have the different types of functions in C, that is the library functions and the user defined functions, and the components of a function, the function call, name, function parameters, the local and global variables, the return statement, and so on. The working of a function, how the compiler first sees the main function, it checks for the function call, it checks whether there is a function defined like that, then it checks whether the function definition is in match with the prototype, and then it executes the function, then it has to return the value to the called function that is to be collected by a variable. And classification of function based on the arguments and return type is what we had seen. Function need not have arguments as well as return type. It may have one or more arguments, no return type. It may have no arguments but it may have a return type. It need not, it may have both the arguments as well as the return type. So in all these forms we can declare and use functions in C. So these are the basics of the functions. We will be seeing in detail about the functions in the next sessions. Thank you.